Welcome to this next session within the world of electrification and automation. I'm Michaela Münekes and I will gladly guide you through this presentation. And I'm happy that my dear colleague Ayla Kleemann is now with me right here in the studio. And she will talk about the digital caretaker for electrical distribution systems. And please feel free to post your questions at any time during the presentation. We will answer them live at the end of the presentation in the dedicated Q&A session. I will be your voice, read your questions aloud and address them to Ayla. And the expert will answer. That's why we are here for you to answer your questions. And one question we receive rather often, and I will answer it directly. We do record the session and you will get access to the recording. Ayla, I think you want to focus on reliable power distribution, and our auditorium should learn about the benefits of the digital caretaker. Ayla, the stage is yours.
Thanks, Michaela, and also hello and a warm welcome to the session Digital Caretaker for Electrical Distribution Systems. My name is Ayla Kleemann, and I'm the Head of Sales and Business Development for IoT and Digital Solutions within the Electrification and Automation Business Unit. I'm happy to present to you our Nxpower Monitor application. Let's have a short look on the content for today. I will give you a short introduction and an overview of the addressed use cases and pain points before we deep dive into the topic of condition monitoring. This part is split into three parts: temperature, circuit breaker, and partial discharge monitoring. Afterwards, we will have a summary of the benefits. Today, we want to devote ourselves to the topic of digitalization. Everyone uses digital solutions and technology on a daily basis, both in their private and professional lives. Buzzwords like IoT, Industry 4.0, smart factory, and predictive maintenance are on everyone's lips. But what solutions are available in the energy distribution sector, and what requirements from sensors to applications are necessary for this? With this question, I will deal in the next minutes. We ask our customers what their pain points in daily operation and maintenance are. So what keeps them awake at night? What we have heard in the most cases was that a shutdown is the worst scenario. To avoid, they have to implement field checks, especially for aging assets. That also fits with the survey. According to the Association of the Industrial, Energy and Power Industry, 60% of all industry customers and companies have experienced at least one power outage in recent years. Even if the supply is quickly restored, the resulting loss of revenue can quickly reach 6 figures or higher. Additionally, it was often mentioned that they are dependent on specialized personnel to know what is happening, either to make a field inspection or to go to get access to existing systems for a report. In short, to sum it up, there's missing transparency of electrical distribution assets. There is little optimized energy savings and operational efficiency, fear of unplanned downtimes, and high effort for manual and frequent preventive maintenance. Also, there is the wish for possibility to reduce the carbon footprint and so-called vendor-agnostic solutions to establish a safe and comfortable environment. Based on this, we derived the following 4 use cases to achieve OPEX savings, CAPEX deferment, risk management, sustainability, and safety. To address the topic of missing transparency and periodical travel to substations and easier derive of decisions, we collect several sensors and relay data and provide easy access to these informations through dashboards, which supports at the end the decision-making process. To avoid unplanned shutdowns, we have an online health status monitoring of connected equipment with immediate alarm functionality. In the next chapter of this presentation, we will see how that looks in detail. Additionally, we address the topic of energy monitoring by visualizing energy consumption trends and KPIs like, for example, CO2 emission and energy budget forecast. To have all kinds of documentation which is necessary to do maintenance and operations, we have a documentation repository to have all important information in one place, accessible at any time from everywhere. The Nxpower Monitor is a web-based cloud application for electrical distribution systems on the Siemens MindSphere, the leading industrial IoT as a service platform. The application seamlessly supports energy managers, maintenance and repair personnel in their digital transformation, regardless of whether it's a new or an existing plant that is being digitized. Nxpower Monitor is a comprehensive application that provides visibility into your medium and low voltage switchgear, as well as transformers and other electrical equipment. This means you have one application for all electrical equipment in existing and new plants. Based on real-time data from the previously mentioned sensors, the app provides component health status, current operating data, alarms, and energy monitoring and documentation. With these features, you achieve savings in operating costs, deferral in capital costs, and improved risk management. So with this, the traditional portfolio gets digital. To sum it up, here you see an overview of the key features of Nxpower Monitor, which is suitable for greenfield as well as brownfield projects. With asset transparency, you have instant access to any location. One of the most features is the health status, which gives you immediately a hint where problems occur and where you better have an eye on it. The operational view shows you all operational values and status information to support decision making. The alarm overview, including statistics, supports better service and maintenance planning. Additionally, the documentation possibility supports the service technician in their daily job. And the last feature we provide is a basic energy monitoring to compare the energy consumption of the feeders over substation locations with each other. Sometimes we hear the question, but why should I invest in IoT? And why do I need it? I have already an existing SCADA system. Simply, you can compare it with the following. You are driving a road along on the SCADA is simply for operation. It's like your steering wheel you have here. You can turn along the road to the side left or right. You know, so basically where this is going to. But you don't have the details. So you don't have the details on the feeder level itself. You don't have the measured values really, which helps you in, for example, a motor or the brakes. So all this is normally not visible in your SCADA schemes or in your SCADA applications at all. So for that, we simply developed here this application. You can compare it really like a driver assistant and fault evaluation system. Additional sensors like you have in the car are making your life easier and simplify operation and maintenance. After the overview, let's move to the next chapter for a deep dive of condition monitoring and how it is implemented on field as well on the cloud side. When we talk to our customers about digitalization, 80 to 90% of the time we hear questions about condition monitoring and predictive maintenance. Today, we first want to clarify the question of why, in order to go into the second point in detail, which type of condition monitoring is possible and which problems are solved. The last point relates to the concrete implementation of condition monitoring systems. Electrical components, be it high voltage, medium voltage, or low voltage, transformers or motors, are of course developed, produced, and tested as individual components at the highest level. Various IEC standards stipulate which type tests are mandatory. In addition, of course, the OEMs carry out further tests and quality assurance measures. But as everything is picked and connected on site and put into operation, failures can occur in rare cases. This can also lead to later failures. Of course, this doesn't happen often, but every 3 to 5 years, which then leads to production downtimes and thus financial losses. In the worst case scenario, they are arcing faults or EHS cases. Really, a lot has to be done to avoid this. But let's first understand together why such failures occur, despite extensive type tests using 2 practical examples. As an example, we have chosen 2 types of switchgear, but it could be, of course, also a transformer, motor, or other electrical component. On the left, we see a picture of a cable connection compartment of a gas-insulated medium-voltage switchgear, and on the right, a withdrawable circuit breaker panel of an air-insulated medium-voltage switchgear. I think the pictures are clear, so that you can immediately see that a hard, serious error has occurred. On the left picture, we can see that the implementation of the L3 phase is badly damaged and an arc has taken place. After detailed investigation, it was found out that the wrong torque was used to tighten the cables. Either the torque was not properly calibrated or it was a human error. This has led to a really low contact pressure, better to a low contact, which leads to a local overheating and ultimately to an insulation damage and an internal arcing fault. On the right-hand side, the problem was on the circuit breaker side. Here too, the contact between the fixed and the extendable part was too low, which led to a local overheating over time and ultimately also to an internal arc fault. Although all components have been of the highest quality and are generally low maintenance, that doesn't mean they don't have to be taken care of. And the consequences are obvious. The arcing faults caused severe damage to the switchgear, which meant that it was out of operation for some time, which in turn led to a loss of production. In the case of the gas-insulated system, for example, it was over 8 hours. In the case of the air-insulated, the failure was about 6 hours. The most common causes of failures in electrical distribution systems, what you see on the left-hand side, are known, and operation and maintenance managers carry out various monitoring measures to reduce. Main causes for failures are loose connections, environmental conditions, and incorrect work. Here are the examples of how condition monitoring can detect these errors really at an early stage and thus prevent failures. The condition monitoring, like mentioned at the beginning, can be split into 3 main parts. Temperature monitoring can detect loose connections, for example, screwed busbar connections or cable terminations, and inadequate contacts, for example, withdrawable circuit breakers. As mentioned earlier, this arises from the fact that instead of the necessary torque for M12, only that for M10 was used at a high speed. We identify local overheating at terminals to prevent power outages and to avoid failures because of corrosion or oxidation. Circuit breaker monitoring is usually done during scheduled shutdowns and checks whether the circuit breaker is working as expected. The circuit breaker monitoring can detect faulty circuit breaker mechanisms and components, for example, tripping coils, closing coils, spring-loaded drive motors, and the switching time. Partial discharge monitoring is not so common in the medium voltage range, but more so in the high voltage range. However, we are seeing more and more inquiries in the medium voltage area as well. It helps in the detection of started insulation faults, which are gradual, creeping faults, which, however, if left undetected, can lead to a shutdown. Partial discharge measurement can detect faulty components installation, for example, medium voltage cable connections, the insulators, bushings, or voltage converters. When measuring humidity, environmental influences often play a decisive factor. For example, the humidity in tropical climates or strong fluctuations between day and night, which leads to a condensation, which then leads also to mechanical and electrical failures. We therefore recommend to start your digital journey. But how can all this be achieved? To see something in the cloud, you need something in the ground. Here you see a typical IoT architecture for an air-insulated medium-voltage switchgear. For the temperature and partial discharge monitoring source sensors, so-called surface acoustic wave sensors are used, which are wireless and energy harvesting. They are connected to a so-called reader converter box, which then can be connected via Modbus TCP/IP connection to the gateway to send the data to the cloud, where they will be analyzed and visualized. The gateway is the collector and interface between the physical and the digital world. The Hall sensors are used for the circuit breaker monitoring and are normally mounted in the low voltage compartment. These sensors are hardwired to a data acquisition device and then to the gateway. All further data we normally get from the protection relays via the IEC 68050 protocol. For a gas-insulated medium-voltage switchgear, it looks a little bit different, especially for the temperature and partial discharge monitoring. Main difference is that the sensors are not mounted inside the switchgear, like in the case of air-insulated, but outside and only in the cable termination compartment. For the temperature monitoring, standard sensors like PD1000 sensors will be used. For the PD monitoring, so-called high-frequency current transformer sensors will be used, and for synchronization of the signal, a Rogowski coil. Only the sensors for the circuit breaker monitoring will be the same, like in an air-insulated medium-voltage switchgear. Principle in general is the same. Sensors are connected to data acquisition devices, connect to the gateway, and then sent to the cloud via encrypted protocols. To make it a little bit more tangible, on the picture in the top, you see how the source sensors and respective antennas are directly mounted onto the bus bars within an air-insulated switchgear and how they are plugged on the cables in case of the gas-insulated switchgear. How does it look like in the Nxpower monitor application? The condition monitoring dashboard shows important temperature data collected from sensors in the field to help you to have better understanding of the substation conditions. It is the base for faster recognition of failures and also for better planning of maintenance activities. You can select the different connected assets like medium voltage switchgears or transformers in the drop-down fields in the top right corner. If you have selected one, you see based on availability of respective sensor, the different charts. To analyze better, you can zoom into it, also into the charts, by clicking the icon in the top right corner of the line chart, for example, for the bus bar. Here you see the temperature and humidity sensors within the busbar and cable compartment for air-insulated switchgears. For gas-insulated switchgear, only the cable termination chart will be shown. In the application itself, rules and algorithms run in the background, determining what health status, which is indicated by the icon on the left side of a chart. For example, if a threshold is exceeded, the light will change from green to yellow or to red and will trigger an alarm as well. In other views, you will see the aggregated health index. Always, the worst status of a component will be aggregated and visualized. Also, the integrated so-called operation counter indicates the remaining lifetime of the mechanical parts and supports you in the decision-making process and optimization of maintenance tasks due to better transparency. The relative humidity chart works the same way like the temperature charts. Beside the temperature and humidity monitoring, as well, the overview of the operation counter from Nxpower Monitor provides the functionality of circuit breaker monitoring, which can be selected in the top. On the first picture, you see how the Hall sensors are mounted in the low voltage compartment with the data acquisition device. In this circuit breaker monitoring view, you get the overview regarding the position of the circuit breaker as well as the spring reserve drive on the top. Additionally, you see 3 charts which give you insight of the electrical lifetime of I²T values and the mechanical lifetime based on operation monitoring of operation counter and inactive time monitoring and ready for operation. Under readiness for operations, the last switching operation of the breaker is analyzed in detail, and based on it, prediction for next operation is done. As a last part, we click on partial discharge monitoring in the top. Besides circuit breaker monitoring, we provide this partial discharge monitoring if the right sensors are in place. Here, partial discharges will be monitored, which helps in detecting possible insulation failures or degradations. On the top, as mentioned before, you'll see the same sensors like we have for the temperature monitoring in case of air insulated. For gas insulated, you see the high frequency CTs, which are mounted on the cables and the Rogowski coil for synchronization of the signals. The different widgets indicating the health status of the feeder, green, yellow and red like before, based on the ratio and EPPC graph and the partial discharge indicator graph. Both are time series graphs. This information is obtained and calculated from the partial discharge sensor available in the feeder to the application. The ratio, low, medium and high frequency, is defined as the magnitude of the partial discharge disturbance in dB. The EPPC, known as estimated pulse per cycle, is the low, medium and high frequency discharge per cycle. In the GIS part, it is a little bit different. There, the calculation and status information directly comes from the device in the field. For medium voltage GIS, it's from a Falcon device, which gives the status of green, yellow or red and alert messages when the status is changing. After looking on the Health tab, let's briefly go to the Maintenance tab on the left-hand side. Another very important aspect is the maintenance overview. The maintenance view allows you to visualize all of the alarms along with their status and details. It also initiates an email notification to your designated maintenance engineers with the exact time, asset type, panel number, and precise event description, for example, when there is a trip of a protected relay. In the first screen of the maintenance view, you see really basic statistics, like the number of open and acknowledged alarms today and in comparison over the time. Additionally, you see in the bottom the top 3 alarms to analyze where the most failures occur. In general, we divide the type of alarms into 2 parts: field level alarms and calculated alarms. The field level alarms will come from, for example, protection relays like there was a trip. The other kind of alarms are calculated alarms, which are coming from the software application itself. The health status has changed, the availability has fallen under a specific threshold, etc. So I hope I could give you a nice overview how condition monitoring works on the field as well as on the cloud side. Now let's have a look on the concrete values. Let's close with a small summary. The application is easy to use so that you can go digital faster. It is elastic because you decide which model fits to your needs and you pay only what you use. Scale further with less cost. It integrates all substation equipment to be really your digital caretaker of your substation. Reliability matters always. With this solution, you get a reliable solution with the decentralized system data in the cloud and all necessary cybersecurity and data protection directives in place. So to recap, one tool for electrical distribution systems. We help you to gain transparency across your electrical distribution assets, identify optimization strategies to reduce your operation costs, better manage risks by identifying potential asset breakdowns and failures before they happen, so you can concentrate on your business by being sure that your assets are reliable and you know before that something will happen. The benefits are, in short, OPEX optimization, CAPEX deferment, risk management, CO2 footprint optimization, optimization of asset utilization. So, start your digital journey and operate your energy supply systems more intelligent.
Thank you, Ayla. That was a comprehensive presentation with a lot of information for me and hopefully also for you out there. And I think we will just take some additional 5 minutes to have some time for questions because there are a lot of questions. So I'm sure we will have homework for you because all questions we cannot answer right now live will be answered afterwards via mail. But we start with one question I found really interesting because coming from local SCADA, the question is, by implementing sensor, we can also send these data to local SCADA. Why should I use Nxpower monitor application?
A really good question. It's not the first time I hear this question. So I think I give a good example. It's like we are really your protection system like you have in the car. I mean, if you have a car 20 years ago, there was no EPS system, ABS, and the whole electronic what you have today. And it's a little bit similar with the switchgear. So what you have, of course, you can also connect it to a SCADA system. But what is in the cloud different? We have a lot of analytics. So all these other algorithms which are running and also getting more and more trained, and we get more and more precise, you can't have in a SCADA system. And that's the main difference. So going really into the way of predictive maintenance is the main benefit of such solutions. And another, of course, advantages, you can scale really easy in a cloud with less costs. And you have, I mean, I can sitting in my home office and I can see all my substation locations all over the world. So in India, in Turkey, in wherever I have any equipment on an asset, I sit really nice in my home office and can monitor everything.
That sounds impressive. And I think the next question, I will put two together because one is how much is the Nxpower monitor software and what is the percentage cost of Nxpower monitor with respect to monitor assets? That probably depends on the configuration, right?
Correct. So it's a little bit dependent based on how many assets you are connecting and how many switchgears. But in general, it's based on the MindSphere cloud. So you need a base tenant that you have the cloud resources, you can say. And then comes the application itself with a price. And that's also split in different modules. Like I said, you don't need everything. So you don't need temperature monitoring, partial discharge, and circuit breaker monitoring. So there are different modules in the software application itself. You can start with a so-called starter package with €300, and then you can add, for example, the condition monitoring part with €200. So it follows a subscription model, but you can every month decide to stop or maybe to add a further upgrade.
Okay, so
it's really flexible.
Yes, that's flexible. So just pay what you need and not buy the whole package and then pick out. That's great. And we take time for one last question. Is Nxpower monitoring offered as a package of a digital solution package, or is it a separate product portfolio from Siemens?
It can be bundled together, I would say. So it can be as a standalone product or software subscription, but of course you can bundle it with a service contract or with our existing hardware portfolio. That means with our switchgears, with the transformers, also with our CCAM devices, etc. Because also we're using these kind of portfolio elements to have the connection to the cloud.
Okay. And why it's called Nxpower, it comes to my mind, is it valuable or working only with Siemens, with NX something stations?
No.
Or
no? Yeah, I mean, we wanted to go in the same direction like our switchgears, because mainly we're coming from this direction and have implemented first for our own switchgears. But it can also be connected to other switchgears of third party, and also third party relays. I mean, yeah, we prefer, of course, our Siemens equipment, and also there, I would say, from an analytics perspective, it's for us easier because really we know our switchgears perfectly. But it's a discussion point, so please get in contact with me. We can discuss in detail if you have third-party equipment, how we can connect.
Getting into contact was a perfect way back to me and back to the exhibition area, because within the exhibition we have always on every booth the possibility to meet via Teams, to meet the medium voltage experts there, to meet the energy automation experts there. Just push the button, let's meet in Teams, and you will be met by our receptionist in a Teams room, and then be taken into a one-on-one discussion with our experts. Ayla is not yet there, because she's still here in the studio, but the colleagues of Ayla are there and they take care of your questions. By the way, Ayla, will you join the chat somehow during the day, or busy with...
I try to join later, but always you have also the possibility to send directly an email to me. And I will answer.
Thank you for that. So just get in contact. If you have questions, contact Ayla, contact us via web forms, get into the exhibition. You just need to decide which way you want to take. So all open questions in the row will be answered afterwards via mail. I already mentioned, if questions come to your mind later, get in contact with us. We recorded the session, and the recording will be made available to you. You can recap the session and review it again. I am now looking forward to seeing you in one of our next sessions. But before you join us in about 13 minutes, and Bernd Schüpperling with digital switchgears for intelligent secondary distribution grid solutions, I thank you very much for participating in this session. Ayla, thank you for the interesting presentation. There was valuable information in it. Thanks for answering all the questions. And now take care and see you soon.